Hello and welcome back to the channel. And as you might tell, but what we're seeing here on screen, today I would like to talk a little bit about shaders in Godot. These are really cool. We'll take a look both into the coding the shaders as well as creating the visual representation of them with the visual graph for shaders. Um, Today we'll just work with these two very simple shader, but I intend to make this into a series where we will try to look into increasingly more complex and more difficult, but also more useful shaders. Let's start from the beginning. I'm going to create a new project. As you can see, I am using the latest 4.2 version of Godot. Let's go to new, find a proper place for this. Let's create new folder. And let's start creating. So in today's episode, we'll focus on one type of shaders that are applicable to 2D. So let's switch there. I'm going to create empty node, call this main, as I always do. And let's save this and let's designate this as a main scene. Okay, so first thing that we need to do is to create a 2D node to which we would like the shader to apply. So let's find a sprite and we can basically add any texture to it. I'm just gonna use the icon for the simplicity. Okay, let's maybe put this in the middle. And first, let's try and discuss what shaders are. So shaders are the simple scripts or programs that can be run on your GPU to directly influence how given 3D or 2D object is being drawn into the screen. This gives you the ability to manipulate the position and the color and also other properties of 2D or 3D object, vertex by vertex or pixel by pixel, if you'd like, for 2D. This gives you a lot of power when it comes to creating VFX in your game. So most things like spell or magical effects, stuff like fog, or for example the fire, or some kind of chill effect, the muzzle flash in the gun, those all can be achieved via shaders. And creating and writing them is a little bit different than just writing scripts that we did before in GDScript. One, because you have to change your mindset a little bit when it comes to writing stuff, but also because they're using different language. It's not GDScript, this is a shader language that was a little bit changed and maybe a little bit modified to fit into Godot script. But for now, let's focus on creating our first simple shader, which is going to be a grayscale shader that will allow us to basically turn our texture into a grayscale image. So how to create and apply the shader? You basically do this by manipulating the material. So let's go to the material in the inspector, and here from the drop-down choose new shader material. It's going to create the new material, and then we can choose new shader. And here is a very important thing when we create shader, there are two types that we can use. There's a shader and visual shader. The standard shader will allow you to write the shader code in GLSL, I believe it's called. The visual shader, on the other hand, will allow you to create a graph, which might be simple for some people, but I will show you that basically everything that is achievable via shader language, you can create it the same way, or you will get the same effect when using visual shader. But I would like to start with the programming language. Then there's mode, which is basically to what type of node this shader should be applicable. The spatial is for 3D. The canvas item, as the name suggests, is for 2D and then optionally UI. Particles are for particle effects, and there are special types of shaders or modes for shaders for sky and fog. In today's episode, we will basically focus on canvas items, meaning 2D. So let's create that, and I'm going to call this Grayscale Shader. And this is going to create new file and also apply it here. So I can click it, and this is going to open shader editor. Okay, and this this comes with 3 functions predefined. Here at the top you can see the shader type, so the mode that we have chosen. We could also change it here to spatial, and you can see that the autocomplete is kicking in, but we'll stay with the canvas item. The light, we will not bother ourselves with that yet, but we have 2 functions here. One is the fragment and the other is the vertex. And basically the rule of thumb is the vertex can be used to move the vertices, so change its position on the screen, and we'll use that today. And the fragment is basically the same. I mean, it's also applicable to every pixel, but if it's a pixel, then you can use it for stuff like, for example, changing the color, which we will do right now. So since I won't be changing the position for that shader, I'm gonna get rid of the vertex. And one thing to have in mind here is this is called to calculate some property for every pixel in your material or in your node. That means this is basically a loop, right? So this, let's create a simple script, is basically like writing something like that. For I in X, where X is the position from 0 to max pixel in the x-axis, and for J in Y from 0 to max pixel Y, call the fragment and do something with it. So this is going to get called in a loop for each and every single pixel. And let's get rid of that since we don't need this. Okay, so let's try and change the grayscale of our image. And what is cool is you will see the effect of the shader running directly here in the editor. So there are properties in the shader that I can change. One of these properties is color, okay? And this is in RGBA format, meaning this is a vector of 4. And if you'd like to manipulate the color, you might think that you can just say, oh, it's 255, right? 12, 1, 6, 8, and 1, for example. But this isn't going to be correct because the shader language is quite different than what we know in a standard programming languages like C# or GDScript. because it sends the instructions directly to GPU. So to manipulate the color, I have to use the structure that holds 4 values, just like R, G, B, and A. And here we can see that we have special structures like vec2, vector2, vector3, and vector4. Since we would like to have like four values here, we'll use vector4. And here I can start specifying some values. So if I would change this to 255, 255, 255, and 1, and then I have to end this with semicolon, you can see that this turned all white. So I have the power to directly influence the color. And if I change this to something like 0.5, now you can see that this is being changed. So how to create and control the grayscale of our image? I can define the variable here and call this grayscale and say that the grayscale is color.r, so I can read the colored channels, color G and color B, and I can then divide it by something and maybe multiply by, no, let's multiply by 10. And I can use that grayscale. Oh, the values, the type of values has to match, so it has to be float. Then I can use this, basically say this is vector 4 of grayscale, grayscale, and grayscale, but reapply the alpha channel here. Okay, and then I can control this, right? The one problem with all of this, let me change this, for example, to 1. You can see I still maintain the texture underneath it. The one problem with this is right now we don't really have much control of it, right? So if I would like to control this a little bit, I could say let's define uniform float grayscale intensity, and let's set this to 1. And now you can see one thing. There's a shader parameter here that can be controlled by me, right? So if I set this to 0.2, oh, I'm not using it yet, sorry. Let's apply this here. Now you can see that I am able to control the grayscale via parameter, which is great. One thing you might ask yourself is, sorry, what does uniform mean? Uniform means it's uniform throughout the whole lifetime of a shader. So this, you can think uniform of being a constant with a very well defined type. Okay, so uniform is basically like a constant. So this is already useful because we can use grayscale intensity here to manipulate how our color is calculated. But what about using that parameter in a code to control our shader during runtime? So if I hover over this, you can see that there is property, shader parameter grayscale intensity. So let us try and write a simple script that will control that. So let me see. This is extending sprite to D, right? And there should be a ready function. And then I can say itself. Let's see. So we can just write material as shader material, because we know it is a shader material. Set shader parameter, and the parameter name, we know that this is grayscale intensity. So let's try this. Grayscale intensity. And we can see that the grayscale intensity is set to 0.5. Let's try and set this to 0.1 in our script. Okay, so this is how it looks. Let's try running it. Oops. And we can see that this is definitely darker. Let's change this to 0.9. Yeah, and this is lighter. So this is how you can control that shader property from code. Now let's try and create the very same shader by using the visual shader editor. Hi guys, just a brief intersection. A quick reminder that you can now support the channel by joining with the membership for YouTube. And if it's too much for you, and I can understand this is PLN by the way, but you will see your own currency. You can also support me by buying me a coffee here at Buy Me a Coffee or in /cyberpotato. The people that supported me one or the other way will get the priority when it comes to the suggestions for the next videos. Also, there's a Discord right now for you. A link will be in the description. One thing that you have to do when you log in is to read through the rules, then click on the potato here below and you will get the access to the whole server. Thank you very much, and let's go back to the video. Let's now try and recreate our grayscale shader with visual editor. So I'm just going to duplicate the sprite, move it here a little bit to the right, and in the material I'm going to create new material. So let's clear and let's create new shader material and new shader, and this time I'm going to choose visual shader, and let's call this visual grayscale. And one thing that you might notice is that even the extension for the file for the shader is different. This is a resource, while this is GD shader. Let's create. This is applied, so we can click this, and here you can see the visual shader editor. So here is the one node that we'll always have, which is going to be the output. So what is the actual result of running the shader? And here we have the properties that we can manipulate. But you can see that this is going to change if I'm going to switch from fragment to vertex. Right now we have the vertex, the UV, color, alpha, and point size. But for the fragment, we have a color, alpha, normal map, and stuff like this. So that means that the output properties of the shader, as I said before, are different for the fragment function and for the vertex function, and also for the light function. But we're trying to recreate what we had here in the GD shader, so we'll use the fragment, but you can switch this right here. Of course, you can use mouse to control your position, so the middle mouse will move you around the shader editor. Then there's the zoom, which is controlled by scrolling the middle mouse button. I believe here you can see that I can switch the graph which is like the minimap of the visual shader. This comes in handy, especially when your shader is pretty extensive, which it can be when you're building really complex visual effects. But let's switch this off for now. So let's start by trying to apply the very same external parameters. So as you can tell, we were able to manipulate the external float parameter called Grayscale. You can do the same here. So what I can do is just here, I'm going to click right, and that's gonna open the pop-up window where I can search for nodes. So I will just write float and I will try to find float parameter. And here it is. And I'm going to name this Grayscale, just as we did before. Okay. And then we need to think about what we're actually doing here. So first thing, as you can see, we were reading something from the color property of the shader, then dividing it by 3, and then multiplying it by grayscale intensity. And in the end, we took that grayscale and we constructed a vector 4 from the grayscale and from the color, and reapply that to color. So first thing we have to do is to read from color. So here I can just search for color, and here under input I can find this. So now I have ability to use that in my shader. And then if I take a look here, what I did is I read from the deconstructed properties of that color vector. So I have somehow to turn my vector into singular properties. And this can be achieved by using vector decompose. So, but I need vector 4, so I can just click on this and change the type to vector 4, and now we have 4 outputs. So here, as you can see, these are the input and output points, and what you can do is just drag and drop those to connect the nodes. So what is happening here is our input, and here you can see all of the inputs that are available to you. Now it's being decomposed into the values. These are called X, Y, Z, V, but we know that this is RGBA channel of the color. Okay, then what is the next step? They are all being added, the R, G, and B. Okay, so what I can do is I could add node and search for add, and there's add operator, right? And here again, you can very easily use that drop-down window to see all of the mathematical operations that are available to you. So now I can just add X and Y, which is again R and G, and then I can duplicate that node, set this a little bit further, and since addition is additive in mathematical terms, I can just add the result of that operation and add the B channel here. Okay, then going back here, I know this is divided by 3. So first thing I'm going to do is I'm going to add a float constant, not a parameter, but a constant. I'm just going to say that this is 3, right? And then I can divide those two values. So I can just search for divide and divide those two values. And what I did there is I can add the node by clicking right, but I can also drag that output and let it go. And that's going to place that node with the input connected, right? And here, if I'm searching for multiply, I can just press create. And now you can see that the first input is connected to the result of that operation. And this has to be multiplied times our grayscale intensity. So just book, drag and drop that. And then finally, for the color to work, we need to construct this, and I can just drag and drop from that and search for compose, which is going to be vector compose, and here I can even find vector for compose. Perfect. And now I can apply my values. So here, everywhere we apply the result of the multiplication of that expression with grayscale identity. So I can just say this is connecting here, here, and here. And then in the end, as you can see, we are using the unchanged color alpha channel, right, that we read here. So it doesn't change at all, meaning I can just get this because the sorry, W is going to be our alpha channel, and plug it here. And now if I take a look here, we have shader parameters, grayscale. I can just say 0.9, and here we have 0.5. So let's see if those look the same, and they do, which shows us that we can basically achieve the very same result both when it comes to coding and visual grayscale. And does it really matter which one you would use? Not really. Both are fine. If you prefer coding and you would like to use shader language, this is your way. If you're more of a visual thinker, you can also achieve the very same. I would say maybe coding them in the end is a little bit better because your knowledge about the shader language is going to be applicable to other software that allows you to write shaders, like for example Blender, or in a web when using WebGL. So maybe this is a little bit better, but when you're building a game in Godot, this is fine too. Okay, so in the next section, let's look into another simple, fun shader that allows you to control the vertex of your sprite 2D to do a little circular movement, and we'll recreate it both in a code and using the visual shader editor. So let's take a look at an example of what can be achieved with the vertex function in a shader. So again, I'm going to duplicate our sprite 2D, put it here, and I'm going to create a new material. So let's clear new shader material, new shader, and I'm going to use the standard shader. So we will be coding this, and I'm going to call this, let's say, cost scene 2D shader, and save. Open it up to run the shader editor, and we'll not use the fragment and light, so we can get rid of this. And here what I would like to do is change the position of the vertex, and there are many ways to achieve this. One thing I could do is just say vertex, which is the shader property, the same as color, and say plus equals vector2, and let's say 10 and 10. And as you can see, this will move all of the vertices to the given vector, or offset those by a given vector, which is pretty cool. Sorry, but not really interesting. So there's a way more interesting property that we can use here, and this is called time, right? And yeah, it's gonna go really fast, so can we even scroll that far away? Let's maybe divide this by 100, and then let's see what happens. No, of course, this has to be okay. So I don't know where you can notice, but this is slowly moving away. So maybe let's just say okay, I'm not sure I'll be able to present that. Let's go back to what we had before. Okay, maybe try it this way. Oh, it's gonna, the time is flying so fast that it's just going to go away. But what we can do is by using just a little bit of math, we can make our wonderful icon go round and round by using trigonometry. So I can just say use cosinus function, apply time to it, and multiply this by 100, and now you can see that it's moving left and right, which is pretty cool. But then this can be combined with sinus function, apply a time to it, and also amplitude, and now we have our wonderful shader moving all of our vertices simultaneously in a circle. And this of course can be extended by saying uniform float amplitude, and let's say this is going to be 100 by default, and then you can reapply this here. Okay, and then in shader parameters I can maybe change this to 20, and now the radius of the circle is smaller, or bump it up to 200 to make it go faster at the very same time in the around this central point here. So this is pretty cool. And in the next section, just to remind you that we can achieve the very same result with Visual Shader, we'll recreate that simple function in Visual Shader. Okay, so how to recreate this with a Visual Shader? Let's start by duplicating what we have here. We will clear the shader material, or simply create new shader material. New shader is going to be Visual Shader, and let's name this scene again. And let's open it up and let's start working on it. Let's start by switching our function here from fragment to vertex, and let's discuss our inputs. One is the amplitude parameter, the other is the time parameter that we get from the shader itself. So here let's search for time, and we have the input time, okay? And even here in description you can see that this is translated to time in Godot shading language. So let's use that. And also we need the amplitude as the parameter, so let's search for float and let's find float parameter. Let's call this amplitude, and now we can start working on it. So let's find the sinus function, and let's find the cosinus function. Where is this? That one. Okay, and again, if we click on this, we can see all of the possible functions, mathematical functions that we can use. Okay, then what we need is we need the multiplication. So let's find multiply, and let's duplicate this, and in both cases we will multiply the result of running sinus or cosinus function with a time argument times amplitude. This times this, and this, and this. And in the end, what we have to do here is, so we have that and that, and what we have to do is construct a vector2 from it. So let's search for vector compose, and let's find vector2 here. And for any reason I can't, oh, now it works. Okay, so we apply this, and this gives us vector. And in the end, what is really important, we can't just apply this to a vertex, because it's not going to work. Because if you take a look at our Godot shader, what we do is we take the previous vertex position and add the result of running that expression to it. So we have this plus equals here. So we have to read the previous value of the vertex. And this is easy because we can just duplicate the input, put it right here, and here we have vertex. Okay, and from that we know that we have to do the addition. Okay, and then we do vertex. And what we have here is, since we have 0, that's not going to work. But if we apply 100, let's see, it is still broken. And I know why it was broken, because here I had, let's see, I used add for floats, right? Float operation. But here you can see, but taking a look at the color, this is blue, which means float. This is pinkish, which means vector. So I have to use the vector operator. And here we have vector2 operator. So now if I add this and add this and this to vertex, and apply the amplitude, now we have the very same result. One thing you might see is that this is moving clockwise and this is moving counterclockwise. This is because of the order of the functions. So if I'm going to change this to cosinus and this to sinus, and now it's the same. But you can play with those and see actually what type of result can you get. So as you can see, these are pretty cool. But for example, if I set a cosinus here and cosinus here, this should go diagonally, which is pretty interesting, right? But this is how our circular shader can be represented in visual shader editor. And that's going to be it for this tutorial. This is a little bit shorter, but I didn't intend to make this about series because I find that shaders are pretty interesting and a lot can be achieved with those.